Welcome, viewer, to part 4 of the TitanBot series. In this episode, we're building a battery tray. This battery tray has tabs that mate with the indexing slots on the vertical frame rail that we built in part 3. This battery tray also has a compliant latching mechanism that holds onto the battery when the battery is inserted into the TitanBot. Let's get started. Begin by creating a body and creating a sketch. We're going to put this sketch on the XY plane. And because this part is symmetric, we are going to begin by modeling just half of it. Grab the polyline tool, and we're going to create this basic shape here where we create 3 tabs. And we will clean up the horizontal and vertical constraints on these tabs here in just a minute. Once you've roughed out your 3 tabs, we're going to also include a spot for the retaining flange at the back of the battery box. That way, when the battery is inserted, this will be the 0 position of the battery. So this will keep the battery from sliding out of the tray, but also make sure that the battery is balanced, its center of mass balanced in the center of the TitanBot. Alright, so we have a number of lines here that are not vertically aligned, so we're going to fix that first. And after we've done that, we will fix this one line here that needs to be horizontally aligned. Alright, so we've got the horizontal and vertical alignment fixed. What we're going to do now is we're going to make sure that all of the vertices at the bottom of our tabs are collinear. So we'll select them all and we'll horizontally align them. And now we're going to make sure that the edge of our tabs are all the same length. And so we select them and set them equal to each other. So I should now be able to just grab one tab and see all of them change in height. Now we need to constrain our dimensions. Let's begin by making sure that all of our tabs are going to be the same width. So we'll set those equal to each other. And now we'll set the width of our tabs to 10 millimeters. We're going to set the height of our tabs to 3 millimeters. And now that we have set the dimensions for that, let's set the space between our tabs here. And this space is based on the spacings that we created in our vertical frame rail. So we're going to set this to 22 millimeters. And this gap and this gap are going to be the same, so we can set them equal to each other. And we're not going to set this gap here. Instead, what we're going to do is we're going to set the width of this tab over here. It's going to be slightly different because this is the retention flange. We'll set this to 9.8 millimeters. And now we need to set the overall length of our tray. So I will begin by making sure that it's closed. I can see I don't have a line segment here, so I will grab a line segment and close the shape. And I'm going to make it so that this shape that we're creating is symmetric around the y-axis. Good. And now let's set the overall length of it. So we'll set the length of our part to 104 millimeters. And we're going to set this space right here. We're going to set the lead-in for our battery box, or battery tray, to 10 millimeters as well. And now we've got just a whole bunch of noise on our screen here because we've got all of these different constraints. So what we're going to do is we're going to hide those. And we're going to go into the filters. We're going to show all filters. And we're going to turn off all of our constraints. And then we're going to turn back on just a few of them here. So we're going to turn on the values for our distance, our values for symmetry, and our values for diameter. So let's turn those back on so that we're only looking at those. And now we want to set the overall height of what we're building. So we'll set this to 29 millimeters. And at this point, we now have a fully constrained shape. So let's close out of the Sketcher workbench. And we're going to pad this shape out to 3 millimeters. And now we're going to mirror this against this face here. So I'm going to select our object and come up here to the mirror tool. And I'm going to zoom in and select the edge of the shape that we just created. This is our reference edge, so make sure that we select that. And I'm going to choose OK. So here is our mirrored part. And now we're going to create the retention flange on the end of this. So I'm going to left click on the top face and add a new feature to the end of the battery tray. I'm going to use the external geometry tool and bring in these 3 edges. And now with the polyline tool, I will reference the outside edge of the battery tray here. And we will come in and we will create a 2.5 millimeter sidewall. You need just enough plastic here when it's 3D printed to keep the battery from sliding off the end. So 2.5 millimeters thickness is enough to do that. So we'll close out of that. And we're going to pad the flange out to 5 millimeters. And because we are adding some aesthetic features here, we're just going to chamfer these 2 edges here. So we're going to grab this edge and hold down Control and grab that edge. So we've got those 2 edges that we're going to chamfer. And using the chamfer tool here, we're going to change the type to 2 distances. We're going to set the first distance to 7.3 millimeters and the second size to 5 millimeters. That gives us a nice chamfer on the edge of our flange, and we can close out of that. So now that we have modeled out the retention flange, now we're going to reduce the weight of the tray a little bit by creating a triangular lattice in the center of the tray. So right click on the tray, and we're going to create a new sketch here. And we're going to create 6 triangles, and we're going to use the polyline tool to do that. And we're going to create a small triangle on the edge. And for larger triangles, that will take up the middle of this. So come in, we will straighten out the horizontal and vertical alignment of these triangles here in a minute. Okay, so now we have, we're going to make this one so that it mirrors the one on the end. So there we are. Now we have our 6 triangles. So now we need to clean these up. Let's first make sure that the bases of our triangles are all horizontally aligned. And we want to make sure that we've got a vertical edge on both of these triangles, which we do. Next, what we're going to do is we're going to make sure that we're going to skip over this triangle here, but we're going to make sure that the rest of these triangles are collinear on their bottoms. So we do that by selecting an edge on each one of them. And we're going to perform a similar feature up at the top, but we're going to use construction geometry to do that. So we're going to toggle on our construction geometry and grab the create line tool. And we're going to create a construction line between each one of these triangles. And one more to go here. Now, once we have those construction lines, we need to constrain those construction lines so that they are horizontal. So we'll do that by using the constrain horizontal tool. And now we're going to make it so that the distance between each one of these triangles is the same. So we'll set the construction geometry lines equal to each other. Next, we are going to make sure that the lines or the sides of our triangles are equal lengths. Again, I'm skipping over this triangle here. And so now that we have these slanted edges of the triangle selected, we're going to set them equal to each other. And now we're going to arrange them so that they are referenced to the edge of our battery tray. So I'm just going to view the plane that we're working on here and reference the inside edge of that retention flange. And I'm going to make this triangle here symmetric with respect to the x-axis. So now they will move like that. And we're going to make it so that the edge of this triangle is 5 millimeters away from the vertical edge, and we'll also make it 5 millimeters away from the horizontal edge. There we are, vertical, horizontal. We'll do the same over here. We'll reference the vertical edge and give it a distance of 5 millimeters. All right, so there we are. Our triangles are arrayed now in the middle of our tray. And that leaves this triangle here that still needs to be constrained. We're going to set the width of our construction geometry lines here to 5 millimeters. That will constrain the remaining triangles so that we can now focus on this one. Now this triangle, because we haven't constrained it, will move side to side, so we're going to constrain it to begin with by making sure that these two lines are parallel with each other. We'll do the same thing with the other side of the triangle. So now we can bring this triangle here up and down. We're going to now use the polyline tool, and we're going to create a section at the bottom of this triangle. It's going to look somewhat like this. We'll make sure that we've got the top and bottom of this new shape horizontally aligned. And we're going to grab the construction geometry and we're going to join the construction geometry between our two shapes. So we're basically recreating that triangle. And just like we did previously, we're going to make sure that these edges are parallel with the neighboring triangle. Select those two edges, make sure they're parallel. There we are. Same with the construction geometry. There we go. Grab these two edges, make sure they're parallel, and make sure the construction geometry is parallel. There we are. So now I can move the top of this shape and the bottom of this shape, and it follows the slant of the triangle. We're going to make sure that this new shape is collinear with the bottom with the rest of our triangles. And we're going to set the height of this shape to 5 millimeters. And we're going to do a little bit of work in the center here, but we are starting to become crowded with all these different parallel constraints. So we're going to go back over to our filter selection, and we are going to hide all of the those constraints there, and we're just going to turn back on our constraints related to our distance and the diameter. We're going to create a couple of circles here in a second. We'll bring back that symmetry constraint. All right, so let's turn those back on now, and we're going to come into here. I'm going to set the distance between these 2 points, and I'm just going to make it a little bit easier to see this in the video. So I'm going to toggle our view into wireframe mode. All right, so going to select these 2 points here, and I'm going to set the distance between them, vertical distance between them, to 7 millimeters. So that constrains that. Now we're going to add 2 circles. So toggle off construction geometry and grab our circles. And I want to make these circles so that they're symmetric in the center of this triangle. So I'm going to grab the construction line here, start at the top of the triangle, and come down to the bottom of the shape here. And now that I have that construction line, I can click the center of both these circles, click on the construction line, and I can constrain these circles symmetric to that construction line. We'll make both of these circles equal to each other, and we're going to set the diameter of these circles to 2.8 millimeters. These are going to be mounting holes for a current sensor that we're going to be adding to the board a little bit later. And now we want to set the distance between these 2 circles to 15 millimeters. And the last thing that we need to do is set the distance of these 2 circles so that they are 1.5 millimeters. Just got to make sure we click on both those lines there. There we go. We set that to 3.5 millimeters. So there we are. 3.5 millimeter distance. That puts it right in the center of this shape that we've created. We'll zoom back out here and we will flip from wireframe mode back into our normal shaded mode here. And we are fully constrained, so we can close out of this sketch now. And we're going to pocket these shapes. So click on the sketch, make sure they're highlighted in green, and we will click the pocket tool. So there we are. Our shapes have cleared all the way through. And the next thing that we're going to do now is we're going to create the compliant clip that will hold the battery onto our battery tray. So we're going to rotate our view. We're going to find the front of the tray and left click on that face, and we're going to add a sketch. So we're going to use the external geometry reference tool. We're going to reference that bottom edge there. And now we're going to use the square tool. And we will create a square that's symmetric around the y-axis. Rectangle that's symmetric around the y-axis. And we will set this to 10 millimeters. And we will give it a height of 1.5 millimeters. The idea is we are printing in PLA, and if we make it too thick, we won't get this clip to flex. And if it's too thin, the clip just won't have any strength and it will bend and stay bent. So 1.5 millimeters seems to be sort of a happy medium in terms of thickness for what we're trying to do. All right, so that's fully constrained. We'll close out of it, and we will pad this out to 10 millimeters. And now we need to create the actual retaining clip on the end of this feature that we just created here. So we're going to right-click on it and create sketch. And we're going to use the external geometry reference tool. We're going to reference the end of this mount that we created here, and we're going to grab the rectangle tool, and we will create a rectangle here. We've got to make sure that we bring the edge of that all the way over with constraint coincident, and we will set the width of this feature to 2.8 millimeters, and this makes sure that there is enough room for our battery box. Okay, so once we've got that, we're fully constrained, we can close out of it, and we're going to pad this retaining clip out to 5 millimeters. Now we need to create a little ramp on the front of this retaining clip because we want the battery to just slide over it. So we're going to use the chamfer tool to do that, and we'll set this to 2.4 millimeters. That will give us a suitable ramp for the battery box to slide over. And we have a certain amount of weakness right here at the interface between the battery tray and the compliant clip. So we're going to add a little bit of support here. So we're going to left click on the mount for the retaining clip, add a sketch there, and we're just going to use the view section to make sure that we're looking at the edge right down there where the mount connects to the tray. And now we're going to use the rectangle tool, and we'll create a small rectangle down below just like before. We'll make sure that we constrain the coincidence there, and we're going to set the width of this feature to 1 millimeter. And we will pad this out now to 1.5 millimeters. That brings it up to the level of the top of the tray. And we're going to put a chamfer on this edge here. We're going to change it from a equal distance to 2 distance type chamfer. And we'll set the first size to 1.4 millimeters. Leave the second size as 1, so we can see that we've got a little bit of support here that will build into it, so we can close out of this. And the last thing that we're going to do is we're just going to put an aesthetic fillet on the end of our battery tray. Actually, it's more than just aesthetic. It does help create some clearance between the end of the tray and the wheels, because we have some pretty tight tolerances that we're working with here on this design. So we're going to give it a fillet of 3 millimeters. And here we have the completed battery tray.